Liquid nitrogen and dry ice are typical cryogens used in research laboratories here at Rice University. Typical applications can range from storage of biological materials to low temperature chemical reactions. Mishandling of these materials without the proper PPE and training can lead to serious bodily injuries and potential damage to your laboratories. In these sets of videos, we'll be covering some basic safety guidelines that will help you use these materials safely. Without the proper PPE, all cryogens can cause significant thermal burns. At the minimum, you should be wearing a lab coat with closed-toe shoes, thermally insulated gloves, safety glasses, and at sometimes a face shield. Once you have all these on, you're ready to begin. Dry ice usually comes in large blocks such as this. You can use a hammer to break it up into smaller manageable pieces. Be gentle, it doesn't take that much force. Now that we're done, we can transfer these pieces in an appropriate container, such as a styrofoam bucket or any kind of container that is rated for cool temperatures. You should never store dry ice in a sealed container. Doing so will cause overpressurization and will lead to an explosion. Never handle dry ice in a confined area. Since dry ice will sublimate into carbon dioxide, you want to make sure you work in a well-ventilated space or in a laboratory. And remember, never handle dry ice with your bare hands. At the completion of your work, you can store any excess dry ice inside of a fume hood or on your bench with the lid closed. Do not put dry ice in the sink or any waste receptacle, including chemical, biological, or broken glass container. And remember, do not store dry ice in a sealed container. Before using liquid nitrogen, take a moment to understand the equipment and the valves before drawing off your product. The liquid valve is used to dispense liquid nitrogen, which will be covered later in the video. The gas valve is used to draw vaporized gas from the dewar. It is advisable to use a pressure regulator when necessary to meter the pressure of the gas into your system. The pressure builder valve is used to maintain the dewar pressure when there is a significant draw of gas. This valve is not normally used, but it is available if your system needs it. And finally, we have the pressure relief valve. If this tank gets to a certain pressure, normally 230 or 280 psi, it will want to release some of that pressure. Now that pressure is going to be released through this safety valve. It might be a sudden release or a very slow release. But it's important not to be alarmed. It's a safety feature and it's doing exactly what it's supposed to do. It's important never to tamper or block this valve. Now, if this valve is frozen open, you can use water to defrost it, but do not use any external heat source. If you're unsure about this procedure, you can contact Rice EHS. So when you're ready to dispense liquid nitrogen, here are a couple key points to keep in mind. Always use a vacuum jacketed transfer hose and a container that's appropriate for cryogenic temperatures. In this case, a vacuum jacketed dewar. Never operate the valve or the transfer hose without wearing your thermally insulated gloves, and always work in a well-ventilated space. The first thing you want to do is have the hose placed inside of your container and slowly open the valve. This will allow the container to slowly cool down, to which time you can actually open the valve fully. Now, any excess liquid nitrogen can easily be disposed inside of a fume hood by just leaving it inside your fume hood and letting it evolve. Never place liquid nitrogen inside of a sealed container.